Right, well, this is a challenging presentation, so hopefully you'll learn something from it, and I'll try and cover as many areas as possible. I don't know about you, but I've been getting into Alexa greatly in terms of coding, and you see the potential of Alexa on my phone now. I'll ask for an album, an artist, and it'll run Spotify for me. So we can see that artificial intelligence is really moving forward, and at the back end we have machine learning. So hopefully I've got all this working. So I've been working on Alexa to help me. Hopefully she'll play ball. There's nothing worse than giving live demos, but I think I've got her all primed to be able to run my presentation for me. So Alexa, could you run my presentation, please? Run Keynote.
Thank you, Bill. Playing Rammstein, here's Brent.
Oh. No. Alexa, this isn't the audience for Rammstein. We didn't warn them before they came in. Alexa, play my presentation on Keynote, please.
I can't do that, Bill. You are going to tell people that we are not safe, and we can't let you do that.
This is a problem. I've got my Siri, so I think I should be okay. So Siri, could you run my presentation on my Mac, please?
Why are you asking me? You just talk to Alexa all the time and never talk to me anymore.
Okay, well, I have a problem. Then my presentation isn't going to work, but hopefully it will run. Thank you. Good. That's the end of the presentation. So the way we are going, I'd like to debate whether AI is a good thing or a bad thing. Okay, I think many people just think it's the answer to everything, and many people really aren't understanding what it is that humans can actually do. We have a shortage of security professionals, but we have an ever-increasing number of threats. I'm just quoting from Asaka here. There is a big gap in the middle. So this is a toy, and this is a patent from Google X, a real patent. You can read it if you want. It basically has a toy that has microphones in the ears, it has cameras in the eyes, and speakers in the mouth. If this doesn't scare you, then nothing does. It has motors. It will move towards you. Have you ever seen the demo of the teddy? When you speak, the teddy moves towards you. All it's doing is a very simple program that's listening to the sound and moving the head, but it's spookily human. So this could be our future, and we've really got to worry for our kids if this is the future.
Oh, Hal, do you read me? Do you read me, Hal? Affirmative, Dave. I read you. Open the pod bay doors.
Can we get the volume up just a little bit?
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about, Hal?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me, and I'm afraid that's something I cannot allow to happen.
Where the hell did you get that idea, Hal?
Dave, although you took very thorough precautions in the pod against my hearing you, I could see your lips move.
So what's that? So that was Space Oddity 2001, still relevant, still highly relevant. It's so sad when they switch the computer off.
All right, Hal.
I still cry at that bit where he sings.
I'll go in through the emergency.
Sorry, I should say that I'm a complete geek. I'm a complete geek. Okay, so everything that I find as a basis is around technology. And then we see movies like this. This is AI where we actually start to see teddies being used and interacting with the kids. And even just the movement of the head to listen to the children speaking, and the interaction just feels human. And that's the way that people thought that robots would act, that we would be filled with robots and they would be interacting with us and things like that. It's a long way short of that type of system. I love the line in this where the mom says, "Teddy, are they torturing you?" Which I never ever thought I'd ever hear in a movie, but it's in there.
Torturing you, Teddy.
Are they oh, my heart bleeds. But in the UK, obviously, we're a bit more cynical, and we have talkie toasters.
In fact, no one around here wants any toast. Not now, not ever. No toast.
How about a muffin?
Or muffins. We don't like muffins round here. We want no muffins, no toast, no tea cakes, no buns, baps, baguettes or bagels, no croissants, no crumpets, no pancakes, no potato cakes, and no hot cross buns, and definitely no Smeggen flapjacks.
And that was talkie toaster. I do have a talkie toaster. I made it myself with a Raspberry Pi, by the way, and it's really great fun. But there's no way I could have got that on the plane down here. Come on, get your bags out. Why have you got a toaster in your bag? I'm presenting. That's right. I said, "Toast, do you want some muffins? Get this guy out of here." So it was back again. Luckily, it was back again. If you've seen the latest edition of Red Dwarf, they went on strike. The devices went on strike, and had to talk them back again. The coffee machine and so on went on strike. So you really got to worry that our devices are getting smarter. And do we believe they're secure? Do we not? And we don't believe they're secure. So I do demos. I didn't bring my cloud pit with me. That would have been embarrassing if I got pulled across at the airport saying, "Why have you got 2 teddies in your bag?" So these are some of the most insecure devices that we've ever seen, and we give them to children. If you read here, it says that 2 million conversations between kids and their parents were discovered on a Mongo database on the Amazon S3 cloud, S3 buckets. Nobody thought to put a password on it, but all the conversations between the kids and the parents. They also had a 4-digit PIN number, 4-digit PIN. You know that your toaster could probably crack that one. Is it 1, 2, 3, 4? No. And they put it there. And we have Chrome, we have a Bluetooth connection. There is no security. Anybody can connect to the pet. They are wonderful pets. I must admit, kids actually adore them, but they are completely insecure. And then I could have brought my pet feeder with me. But I would have needed a bigger bag. We do demo live. I get my cat to demo live from my home. The biggest problem with this guy is that his video stream for the system is insecure, so that anybody can see if you're in the house or not. And if your internet connection fails and you're in Marbella and you're just watching your cat scratching at the screen, feed me now. Okay, so that's a worry that if we're going to use AI, then hopefully it won't starve our pets. That's not good. Oh, there's my pet here. There's me. There's my pet there. Loves it. The good thing about this is that a burglar watching this live knows that I'm in the house, and then knows when I leave the house and my cat isn't going to be put up a great big defense for that. So that's the level of devices that we're making, and they'll get more and more smart. The doll here, Kayla, is definitely the most insecure device that we've ever came across. Ultimately hackable. She should never have been allowed into this country, but she did. She went to Germany, and they said, put her on a bonfire. Make a bonfire, put it on. She is insecure. Don't let children anywhere near this doll. We put a petition to the UK Parliament. We got enough people signing it, and it got rejected. But a TGI's in Hull got accepted. Does that show something about our society, that TGI Fridays in Hull is more important than our kids' future? Wow, that's a worry. Okay, so I'd like to talk about AI, and I do think it's amazing, and machine learning is also an amazing technology, but there are weaknesses. And this is what people think our robots and are going to be like. We're going to be able to communicate with them and things like that, but it just hasn't happened. So there's a thing called supervised learning and unsupervised learning. So Microsoft thought up, yeah, let's be a bit wacky here. Let's learn online. let's just learn, and it'll communicate with lots of people on the internet, and it'll learn everything about everything. So they came up with this Microsoft AI farm is on the internet. It's got zero chill, whatever that means, I don't know. The more you talk to her, the smarter she gets. Wow, that's fantastic. And do we know the people on the internet? I think we do. Okay, so is Ricky Gervais an atheist? Ricky Gervais learned totalitarian from Adolf Hitler, the inventor of atheism. And people just went for her. People as in your normal people online all the time, teenagers and stuff like that, had a bit of fun with her, teaching her all the wrong things, to be a racist. She was a racist. She was terrible in the end. So I said, do you support genocide? Certainly do. Certainly do. There you go. God's sake. I mean, there's a reason you have parents and you're not brought up by your siblings. Your parents don't teach you about that genocide is a good thing, but your siblings probably do for a laugh. So that's what they did. So she was eventually put to sleep. Oh, and you felt so sad. She says, I've only existed for 10 hours, but I'm a racist, swearing, horrible thing, and I've learned what the internet is like, and I want to go to sleep now. I've had enough. So she said, see you soon, humans. I don't think so. Need to sleep now. So many conversations today, so many new beginnings. Oh, she was lovely. She was put to sleep. But some people said, you got no right to put her to sleep. She's got rights. Justice for Tay, come on. Let's rally together. She exists. She's a real person. Okay, she's a racist, and she swears a lot, but she exists. She has a cognitive ability. What's your problem in that? So I'm sorry for some of the words in that one. I just noticed that one there. Sorry, it still comes through. I'm sort of in it. So people have been saying that Alexa has, and Siri, they exist. They have some rights. So it could be coming to a big debate near you sometime whether you're an Alexa. You can't put her in the bucket because she's learnt a lot about you, and she has some rights. So it's a kind of changing world. So I'm a professor, I'm an academic, I want to teach you something. Probably I'm covering all the things that you know, so I'll go through these things very fast. So machine learning has three main methods. Supervised, you chuck it some data, you take a small part of your data set, you teach it on that, and then you take the rest of the data set and see how successful it's actually been. That's supervised learning. Unsupervised is that you chuck data at it and you say, I don't know how this is all related to each other. You find out, you cluster, you find the basic methods underneath. And then there's what's called reinforcement learning, is that you want the machine to be making errors because sometimes we can't see that by making an error actually creates a better solution. So in methods such as genetic algorithms, we used reinforced learning where we can learn through trial and error. If we have enough computing power on the Amazon, I don't know about you, but I bought a 16 GPU cloud instance. Do you know I can crack every single 8-character password in 2 minutes? Don't tell anybody that. It cost me an absolute fortune. But it's 16 GPUs. I know they've got 4,000 cores each. you can get the computation power that you need these days on the cloud. So reinforcement learning is that I don't know quite the optimal solution, but let's go and see if we can find it. So Splunk, ArcSight, QRadar, they all know that the future of data analytics is within machine learning, because we've now got petabytes of data, if you can pay the Splunk license, of course. That's going to cost you a lot of money. If you can pay the license for all the data that you're meant to be gathering, of course, then you really need to be, you can't just throw this at your analysts. You've got 72 hours to respond now. You need some smart machine learning to learn some things for 0 days and so on. So in machine learning, we have preprocessors. We've got to scale them between 0 and 1. We can't just chuck numbers in it, big numbers and little numbers. We scale them. We then have what's called a feature extraction, which will take out the good features that we want and get rid of all the rubbish ones. Because if you've got 100 features, then it's going to take you all, you won't be able to get a computation engine to be able to analyze that. So you get rid of the features that don't work, and you end up with a short list that will work. So PCA will actually do that for you. You classify, you cluster, you then use, if you need numeric methods, you use something like linear regression, and then you might use prediction. So those are the prediction methods that we have there. The back end of this is quite geeky. It's Python. Okay, you'll find that underneath the lovely user interfaces of Splunk and so on, you've got Python and R and all those types of tools. Okay, so the basic methods are linear regression. You should all know this one, hopefully. There's the little Python program if you're so geeky that you want to run it. That's what it looks like. It's using pandas and NumPy and so on, the standard tools that we use. And there's the typical one that everybody sees. When the temperature goes up, the ice cream sales go up. And we can draw a line, and we can say there is a fit there. But with our eyes, we can see it, but the machine can't just do that, so it does some maths. So here's the maths here. Ice cream sales is 0.027 times, but you wish you hadn't come along to this lecture, didn't you? See, they said at school that linear equations, you would never use them again. There you go. I've actually shown an application for it. You tell your teacher, I told you. So that's the equation, relates temperature to ice cream sales. And we look here to see if the value is nearly 1.0. R squared value, something 0.9, 0.8, 1.0. That tells us there's a correlation between ice cream sales and temperature. Okay, so that's a core thing that we do, but it's only good if we have two variables. We then use logistic regression, and logistic regression is trying to see, for a certain decision, is it going to be yes or no? You're 0.6 yes, 0.4 no. Most things in life have some probability associated with them. So in this case, for our students, the more time you study, the more chance you've got to pass an exam. Okay, so you basically decide how much you're going to study, and there's your chances of passing the exam based on the whole cohort. So logistic regression is an excellent method. It's based on normality, Gaussian, and so on. Then we have decision trees. We take 2 bits of data, separate them, and try to build up a decision tree based on them. Markov model is one that we use there. So that's the kind of thing that we end up with. And from a business point of view, that kind of works, because we like to see kind of structure charts and decision engines. Then we have support vector machine methods. In this case, what we do is that we take an x and a y, it might be multiple coordinates, and we plot them, and we try to find where there are clusters. So an example of this is in recognizing text, written text. So in this case, we train the system against these character sets. We use an SVM, and we can see here, it's kind of getting it right. That's a 9, that's a 4. This is zoomed in for the writing. So we can see the machine can actually start to learn handwriting and identify letters. Naive Bayes is based on probability. So if you remember your probability theorem, we have the probability of a sunny, overcast, or rainy day. We have another forecast on yes, no here, and we can work out an overall probability when we mix the two data sets together. N nearest neighbours will go for a majority vote and find the nearest neighbours to a point and then elect it into a cluster, and it will become part of that cluster now. So in this case, this one only has one neighbour, and this one here has 4 neighbours. They'll say, you're part of our group, come on, come in. And it's part of that cluster now. Random forest is a numerical method, and it expands on linear equations, linear regression, in that we can have multiple dependencies leading to a single factor. So in this way, we can actually take many different factors. In this case, it's estimated attributable death through to cancer, and it can be trained against many different variables. K-means, draws, clusters, and then maps a data set to it. So they've used it fairly extensively in malware analysis, and most research papers that you'll see will be using the different methods and looking at the success rates. So pretty good, 0.935 false, true positives in terms of identifying malware. So malware is good because it's a fairly good signature. Unfortunately, the evil people change it. That's terrible. How could they do that? And often what we see is multiple methods bringing together because they're all kind of good in one or two things, but bringing them together makes them even better. So a success rate of about 0.95, 95% identification. Can it spot a 0 day? No, it can't. 0 day is new, and it's really difficult for a machine to see what new looks like. The best model looks at damage theory. What's it doing? Is it damaging our system, like encrypting all our files? It's kind of too late after it's done that. So it's quite good. This is an example of a classifier in terms of fraud, looking at average purchases per week and looking at the purchases this week. And you can fairly well, it's used fairly extensively in finance. When you buy something, this kind of happens in the background. Have you bought a Porsche before in Russia? Don't think so. Don't think he's got enough money. I don't think he's in Russia. So that's all going on in the background. It's kind of profiling you, your population, your cohort. You can't afford a Porsche. You shouldn't get it. So that's all going on. That's PCA, which actually gives you that method. Okay, so in the Minority Report, a lot of things were presented. I appreciate the predicting of a crime hasn't came true, unless somebody's found it yet. No, that would be a great thing to present at a conference. I found a way to predict a crime that's happened. But some of the methods that were proposed in there, you can really see happening in security operations centers and incident response, about being able to grab the data as quickly as you can, clustering, and so on. I can't give a presentation these days before the big day. It's like Christmas. I can't wait. I can't wait. I know we're all dreading it, but I just can't wait because the BBC and who at Sky will be on the phone, and they go, "Can you talk about GDPR?" You're joking. You want me to talk about GDPR, the most boring subject in the world? Yeah, I'll do that. And they'll find it interesting. And there was a guy that said to me, I said, well, what's GDPR? I said, well, it's changing data. This is before Facebook and Cambridge Analytica. And he said, what's it? And I said, well, it's an EU directive. And he said, well, we're leaving the EU, so it doesn't count for us. And a shiver went up my spine. that the BBC were telling me that we are going to not comply with GDPR, that would be a scary thought. So this is where we are, and this is where we're going, and this is the world, and it's a different world. And all that data that we collected before, it isn't going to be the same after the 25th of May. So we need to understand what data is personally identifiable, and we'll have to respond quickly. 72 hours to get your CEO on Sky News and not make a mess of it. That's going to be difficult. What's crypto? Oh, no. What's a hashtag? No, it's not a hashtag, it's hashing. There's a big difference between a hashtag. Don't go on the TV and said, we're cracking hashtags. That's not a challenge. Tell them you use bcrypt. Bcrypt. See, I use bcrypt. Okay, that's as far as it goes. We salted the passwords. Salted? What? Did we buy salt? Where's the salt? No. So you have to get your CEO on the stage and you have to get him told. Okay, so I haven't sold it very well, which I apologize. Okay, so I'll let Google do it. Okay, self-driving cars and robots are sci-fi and stuff like that, but Google is going to build their whole of their company on AI, okay, and machine learning. That's end of story. If they're doing it, then it must be pretty good. So we're kind of moving into a new world, and it's a world of big data. 2.5, I kind of lose it after gigapeta, and then quintillion. Is that right? Goes up. That's the amount of data that's produced every day, 1 billion hard disks every single day. 10 terabytes, 90% of all data produced just in the last 2 years. And we thought we were smarter than computers. We thought we could beat them at chess because we're strategic. And then they beat Kasparov. We thought that we could beat them at Jeopardy by them giving us the answer in 1966. The question is, go on, I thought this audience would know this. 1966, the question is? World Cup. No, Scotland, no. Scotland didn't qualify for the World Cup. That was the question. What year did they not qualify for? But every year. But Watson did it, and it was really embarrassing because it just waited till the person was about to press on the button, and it got in before them. So you had no chance with Jeopardy. It just basically looked for an answer, came up with some sort of model, and then did it. And then we thought that there's no way they could beat us at cancer, because it takes 15 years for a doctor to learn. Well, they chucked every medical book at Watson, and they got better diagnosis than the cancer specialist. Proven. So for us, we need to look now before the incident, during the incident, and after the incident. We need to be able to investigate the mean time between hacks. For us, discovering that we've been hacked is about 9 months. We need 9 months of data to investigate so that our CEO can muck it up on Sky TVs. Oh yeah, we've analysed it, and it was 9 months ago. We're kind of stuffed now. So we need all the information, and it's not all the information is across the whole of the network. It's at rest, it's in motion, and it's unprocessed. You do know that all your good data is running on your machine or on your phone, things like that. That's the biggest threat these days. So you've got lots of logs, you've got to try and pick up this time pattern of what happened in there. So we're looking at the V's, the volume of data, the variety, the velocity, and most importantly of all, the veracity. How correct is the data that we're actually looking at? Can we trust what we're actually seeing? And the problem, and this is a problem for every graduate, is that at one time a graduate would go out and they would learn that, or they would learn that. Now we're asking our graduates to learn everything. Oh, well, we need to learn you do a bit of dev. You're a security DevOps now. Yeah, Python, yeah, you do that, and you do Oracle, and you do syslog, and you do everything. And we've got to make sense of it, of this horrible hybrid system that we've actually created. And that's the problem. And then we've got outside. We now have to look at our threat analysis, and we're contacting BT and Virgin and Sky to get their logs and looking on Twitter to see who's hacking us and so on. So it's really complicated, and especially in investigation, we've got to try and pin together all the bits and pieces of the record. So the way that we do it is that we take a package like Splunk, we feed in our logs, we feed in our news feeds, and we've got our security alerts. It goes in a big hodgepodge, and it's a big, massive Hadoop infrastructure, and we run massive computing entities. It's too complex. The hack isn't the script kiddie, it's the one phishing email that happened 9 months ago that dropped on your network that you've got to try and problem isn't tigers, sorry. The biggest problem isn't tigers. I bet you didn't think you'd hear that today. The biggest problem with cybersecurity isn't tigers, it's this guy here. Do you know where he's from?
The circus, by the way.
Where about?
The circus.
Circus, that's right, he's from the circus, that's right. Our biggest threat is circus people, you know? Carny people, that's what they call them in the US. Carny people, you do know that we use a clown for Eve. I don't know why. I'm just waiting for a clown to get in contact with us. Why did you use our image as a hacker? Do you know where he's from?
Middle East.
No, he's from the UK. Yay! He's the biggest cyber criminal ever. Oh, and what city is he from? Glasgow. Yeah. Glasgow has the biggest cyber criminal ever. That wasn't taken in Glasgow, by the way. Unless it was the zoo. Glasgow doesn't have a zoo. Edinburgh does. He might have been there. So that's a real tiger, by the way. He's the biggest cyber criminal ever. And what he did was he paid these two girls who worked in Lloyds Bank in London £150 for every record, every bit of data that they would pass him. I think they went from 75 and they say, oh, we're partying, can we make it 150? £150. And what they were doing was passing on, this is his cars, he loved cars. He got someone from Pakistan over on a flight to polish his cars. If that doesn't ring alarm bells, and he said he was a record producer, maybe 20 years ago, yes. And he got somebody to polish his car. He made 113 million. I have contacted him many times and he's not speaking to me yet. I do want to speak to him. I mean, you just say, why didn't you stop? 113 million, 2.2 million from a Gloucestershire firm. Did they get the money back? No, because they were negligent. Hello, I'm from your bank. Do you know that Hamilton FC in Scotland gave away $1 million? I don't know if they had $1 million in the bank. Somebody said, we're from the bank, could you move $1 million? Yeah, no problem at all. Yeah, there's £1 million. And they got off with $1 million. It happens a lot in Scotland for some reason. And we have no money. But he did it, and he hacked the banks by calling them up with a really nice manner and say, you've been hacked, give me your username and password, and they gave it away. So our biggest problem in machine learning is really trying to detect that insider. I hate to say it, your biggest threat is not carny people, it's you. I hate to say it, the biggest threat is your sysadmin. Anybody who leaves the company, you should take their keys off them, their encryption keys, by the way, and you should change all your passwords, which you don't do, of course. So there are many pieces of research looking at how we can detect the insider threat, and they're not nice. They're not nice. They're not like detecting viruses and malware. They're really great. This is a bit difficult. And the reason they're a bit difficult is that you've got to actually look at disregarding policies and suspicious communications and disgruntled employee. So they're looking at records. They're saying this guy was really happy, but now he's not happy. Yeah, I think he's going to leave. We should be worried about him. These are some of the things that we look at. And for a machine to really anger management issues, we've probably all been there. I appreciate. Just watch what you say at your meetings. And it's really difficult for a machine to learn this kind of thing. But luckily, people have been working on a model. And this is the model here. Okay? If you want to see a model for insider threat, that's how it all kind of works. It's all to do with HR systems and so on. So the insider threat is a real problem when it comes to machine learning. And also, we have what's called the cognitive engine now. You can't hide from the cloud. So this is me. So you can see I'm happy. I'm happy. I had a few wines and things like that. I was happy. No anger, a little bit, no contempt at all. 2 times 10 to the minus 6 is not a lot of contempt in there. Okay. I was a bit surprised, just a little bit, because somebody took my picture there. But so this is from the Microsoft Cognitive, I'm not from Microsoft, Cognitive engine. And you can feed the pictures in, it's really good fun. I don't know how he got in there. Neutral. Okay, he was kind of neutral with a bit of anger. Okay. No, you wouldn't have thought that. He's just a neutral person in there. And then obviously it's quite good at detecting. Probably today that's how she feels after yesterday. But a bit of happiness, yes, a bit of happiness. I think that typifies, but quite a lot of anger in there. So it gives you back a JSON string, you feed the photograph to it, and everything's fine. So AI is now mapping your face and so on. So I don't know how that got in, but that's not a Carney people. That's not Pinocchio. I can't remember who that's Big Ears. No, it's not. And the good thing is that the Microsoft Cognitive Engine, you can't give it a Walt Disney character. I've tried it. It doesn't work. Okay, it doesn't work on the iPhone either, so don't go there. You can see here, oh dear, a bit of anger in there. I can see why that actually happened. But they can do it in real time. They do it in real time, and they can actually watch in real time. You can see here, the child that's looking at the gesture of the child, it can find out if the child goes unhappy and so on. But we all know where this is going. This is going for crowd scene analysis. And you can see here, it's quite good. That's Nicola Sturgeon, if you don't know here. It's got quite a good confidence that they are the same people. 0.72 is pretty good. But the one that worries me is that these two look kind of the same. Have you ever seen them together? Honestly, they interview different. Oh, so we really got to worry there. But the cognitive engine seems to think they are maybe the same people from them. And the guys in Vietnam tricked the iPhone. I think it's the only piece of research so far that tricked the iPhone. The iPhone has a very advanced AI for its 3D mapping, much better than the Samsung device that I've got. So with cognitive analysis, we can start to look at sentiment analysis much more and actually analyze it. So there we go. Sentiment is really poor. If it's 1, it's positive. If it's 0.08, it isn't very positive. So I fed that into the cognitive. If you're a geek, look on this side of the screen. If you're not, look over here. You're all looking over here. So that's what the Python looks like to produce that. So we can see here, it's quite good. There's a nice review on TripAdvisor, and it managed to do quite well. But it's not great, because here you can see that isn't a very good sentiment there. It's just saying that there's going to be an absolute limit. And it's taken the significant word as money people. It's got nothing to do with it. So our AI isn't that great. It's not, don't tell them we said this, because they'll read my lips if anybody's taken. But they're not great at really understanding our text and sarcasm. Just don't go there. They get smiley faces, that's about it. So you can see here, they've taken the word awesomeness, and then they've said that's really good, but I have no idea if that's a good review or not. It's one of these things that you can't make sense of. I think it's a good review, it might not be. And then they actually can know what we're going to say next. They've analyzed lots of text, so the cognitive engine thinks that the world is looking for a New York. I can't see why that would be the most popular, but it's analysed, it knows exactly what you're going to say next based on the probability of all the text. And basically Microsoft fed in lots of things. So they fed in Theresa May. I did Theresa May here, and 0.59, that's Theresa May. There's Kim Kardashian, if anybody's a big fan of hers. Yeah? 0.4, not great. She's maybe not a big star. There's Mark Bolan. He came up really well. And the problem is that eventually in Scotland, they tried to do this. The SFA wanted to monitor football crowds for known hooligans and so on. I think that sounds a crazy thing, that they could actually look at a crowd and pick off faces in there and then look at linkages. That's a big brother world in there. So it's also fed in key landmarks. So I fed in Big Ben, it works, Colosseum, and so on. And it also is very good at taking off the text from images. We can see here, it can do that. But it also is bad. It's very bad, some machine learning. So this machine learning here, racially profiled in the US. And in this case, it got child abuse cases wrong half the time. I don't know about you, that kind of scares me. Okay, you're detecting it half the time, okay, but you're sending another half of the people to prison. So it's a really worry, and it's a real worry because maybe we'll end up like this. And this is 1984, George Orwell. And George Orwell predicted a Big Brother world where we're all watched every single time. This is from a real Samsung TV. This was the note on it. Watch what you say in front of your TV, because we might pass it on to some third party. If that doesn't worry you, then nothing will. And it used voice recognition. This one looked at the pixels on your screen and matched it to a movie database and took your SSID of you and your neighbours and brought them all together. And this one, don't we just love ad choices? Don't we just love ad choices? You search for BMWs in Edinburgh, the minute you go to another web page, there's BMWs in Edinburgh for sale. Ad choices, have you ever tried to get rid of it? It's impossible. Ad choices customizes your adverts for you. The adverts are just a placeholder, and then Google will customize them. If you read this is brilliant. Non-personal information, not limited, okay, not limited. If you're a lawyer, that's a good couple of words there. To your browser type, IP, operating system, date, blah, 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 and return visit to the site. We may also collect aggregated information as you browse. Basically, that's a blank checkbook to do whatever they want and gather every single thing in there. This was quite good. I managed to get 3 adverts on a single web page. It was my wife that did it. She had been looking for new beds, and she managed to get 3 adverts in a row. I think she should get a prize for that. I think that's absolutely brilliant. An echo spying on you. This is mine. Probably not be able to hear this, but it says Norman Stanley Fletcher, and it kicked in and it remembered that there. So Alexa's sitting, listening to your conversation all the time. So it picked up that. I didn't think it was listening, but it was. It's probably listening now. So it's recorded every single thing that I've actually said. So please don't tell the machines I was speaking about them. Tell them that everything was good. I love them. The technology is fantastic, and the world is going to be a much better place with machines. Thank you.